Okay students, so now we'll do question number 2. A tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle 30 degrees with it. The distance between the foot of the tree to the point where the top touches the ground is 8 meters. Find the height of the tree. Okay, so let us see the solution part. So this is a tree. Okay, so let us consider this as A, B. Okay, so AB is a tree, and the tree it breaks here. Okay, and it bends. So this top of the tree it breaks here and it bends, touching the ground. Okay, this is the ground level, making an angle of 30 degree. So when the top of the tree breaks and touches the ground, it makes an angle of 30 degree with the ground level. So this will consider C and this will consider say D. Okay, and the distance between the foot of the tree to the point. So this is the foot of the tree. So this distance it is given 8 meter. We have to find the height of the tree. That means we have to find this height. Total height of the tree will be AB. So you can write let AB be the height of the tree. Okay, and BC is given 8 meter, and here the angle is 30 degree. So we'll write theta is equal to 30 degree. So we have to find AB. Okay, so first we'll consider this right triangle. In right triangle DBC, right triangle DBC. Okay, so we have to find this side DB. Okay, and this BC is known, it is 8 meter. So we'll take the ratio of these two sides, DB by BC. So we'll write DB by BC is equal to, see, this DB is perpendicular and this BC is base, means P by B. So we can write DB by BC equal to P by B, perpendicular by base is tan theta. Okay, so in place of P by B we can write tan theta. So dB by BC equal to, and our theta is 30 degree. So in place of theta we'll write 30 degree. So it will be tan 30 degree. So now we'll put the values. dB is unknown, so we'll just write it as dB, and BC is 8 equal to tan 30. So the value of tan 30 is 1 by root 3. Then we'll cross multiply. Root 3 dB is equal to 8 into 1 is 8, or we can write dB is equal to, this root 3 is multiplied, so if you bring on the right hand side it will be divided. Okay, so dB we got 8 by root 3. Now dB, now we have to find AD also, and you see this AD and DC they are equal because this is the broken part, and this broken part it bends and this touches the ground. So this AD and DC they are equal. Okay, so we have to find DC now. So again we'll consider the same right angle triangle. We'll write in right triangle DBC. Okay, now we have to find this side DC. Okay, so we'll take DC by BC. So this DC is hypotenuse and this BC is base, so hypotenuse by base. Okay, so we'll write DC by BC is equal to, DC is hypotenuse and BC is base, so we'll write H by B. So hypotenuse by base is sec, right? So we'll write DC by BC equal to sec theta, and our theta is 30 degree. So we'll write DC by BC equal to sec 30 degree. So now we'll put the values. So DC we don't know, so we'll just write DC, and then BC is 8 and sec 30 is, what is the value of sec 30? That is 2 by root 3. Okay, so in place of sec 30 we'll write 2 by root 3. Now we'll cross multiply. So dc into root 3 will be root 3 dc equal to 8 into 2 is 16, or dc equal to 16 by root 3. Okay, so we got db and dc. Now we have to find ab. Okay, and I've already told you that this dc is equal to ad. Okay, so therefore ab will be ad plus bd. Okay, and write ad plus db. So ad and dc are equal, so dc we got 16 by root 3. Okay, so in place of ad we can write 16 by root 3 because ad and dc are equal, plus db, and then db we got 8 by root 3. Then we'll take the LCM. So since both the denominators are same, so LCM will be root 3 only, so we'll just add 16 plus 8. So 16 plus 8 is 24. 24 by root 3. We can rationalize this root 3. So we'll just multiply and divide by root 3. Root 3. Then we'll multiply. 24 into root 3 is 24 root 3, and then root 3 into root 3 is 3. So you can cancel 3 8s are 24. So we'll get 8 root 3. So the height of the tree is 8 root 3 meter.